morning, boys and girls. I treat you all as boys and girls today. And let me welcome you to the world of mathematics from the world of chemistry. Already you have done a lot of chemistry, but now let us come to the world of mathematics. Can you tell me what is this? Anyone? Circle. Now, it's a circle with center. Now, with a radius. How do you express this mathematically? Expression. There must be some expression. How do we express it? R. This is R. Okay. Say center A. This is a circle C. But there is an expression how we can write this one. C is a circle with center at A of R radius. Here C represents a circle, but now that I am speaking only for the complex type of variables, for those complex type of variables I am taking a variable Z, right, with the center A and radius of R units. Now if you just remember the last class what I told you, that I have a certain function, this is a positively oriented C, that is its curve, and this is f of Z. As I told you that this Z is resembling the Z, right, and this f of Z is, now if this is a complex variable, then a function with a complex variable is a complex function over there. And this. Now what was my question? What did I prove on that day? Can you please tell me, what did I tell you? That integral over C, that is closed contour integral over C, fz dz is equals to, what's that? I had written something. Come on, recollect. Try to recollect. Area? No. Better. Contour is this. Yeah, closed contour. Value, I am asking about value of this one. With that only we can move further. Small portion. How much? It's 0. It's 0. Now, as I told you that what are the qualities that it has to possess? That this should be a simply connected domain. What do I mean by a simply connected domain? See, I have a domain. This is my domain. This may be of any shape. Please don't go particular on that. This is my domain D. And I have a circle where my function f of Z is in that, and this is with center. I have a center A and it is of radius R and it is a positively oriented. Now my function f of Z is analytic. What do I mean by analytic again? That the function is differentiable, partially differentiable. I told you on that day also, right? The function is differentiable. If the function is differentiable, inside the circle and on the regions of the circle, I'm very particular about this. Inside the circle and on the region of the circle, then the value of this is equals to 0. Now I gave some name for this one. What was that name? Some theorem. Every time madam used to give that example to you all. Yes, Cauchy's integral theorem. So this is our topic today is Cauchy's integral theorem. So what does a Cauchy's integral theorem state? It states very clearly that in a closed contour C, if your given function f of Z is analytic in and on that curve C, then the value of that integral is equals to 0. Now this is done only for simply connected domain. Can we just extend it further? What is this? Again I have a domain D. I'll take the example of our physics, right. This something like a rubber band. If you take a rubber band, how many circles do you find in that? Circles. I'm asking very particular about circles. How many circles, sir? Rubber band is having how many circles if you put it in a circle form? One. 2. How 2? Inner and outer. Exactly. Inner and outer. What is this I have made? The same circle. The same rubber band. If we take the example of same rubber band, this is the inner circle that it frames and this is the outer circle. If I take this one as C1 and if I take this one as C2, both of them are positively oriented. I start from here. I just make a cut so that it will be very visible for you. I make a cut. I'm starting over here and then running like this way, and then it goes this way. That is the starting and ending point for this one is same. But still, the Cauchy's integral theorem, how do we can have the value is equals to 0? Just come on. The same integral theorem, but now previously it had only one circle. Now it is having two circles. Yeah, can anyone? This is the assignment type of question. Can anyone? Yeah, exactly. Integral over C1, what do you mean? And then plus integral over C2. Right, the value is equals to 0. That is, if I write it more clearly, integral over C1 f of z dz plus integral over C2 f of z dz is equals to 0. It's not only in the case of one or two circles, you can extend it. So this is for simply connected domain and this is for multiply connected domain. Now, can you just derive the formulas for simply connected domain as well as multiply connected domain and find the values of, if I say that I have a particular question for you, that this is C and this is 1 over z square, this is dz, where C is defined as modulus of z minus 2 is equals to 1. What does this mean? This is a circle with center at 2 and radius of 1 unit. Yeah, thank you.